let's call it social event state. Okay. So as an abstract class, we want anything that implements this to go ahead and get a string name, and description. So actually pretty simple. And the idea here being, this could be something that's powered by a database, but depending on what state the event is in, it's going to define some other behavior. All right. So we did that. I'm going to commit this. And sync it. All right, next up is create a context to implement the abstracted contract. So this is going to be our wrapper class. Go back into model. So add a new item. Called social event context. So hang on. Okay. So we're going to want this to wrap something. So for our context, we're going to use it to extend a social event in detail. And as one of its properties, we're going to give it a social event state. We're just going to call that state. Give it a getter, a setter. Okay. So far, so good. And because we're deriving from the event detail and creating this wrapper class for the detail, we have access to all the properties that the event detail does. So inside of our constructor, where we say social event context, we're going to take in a name, description, if we gave it one, I think we did, date time, which is the start time, and date time, which is the end time. We'll go ahead and assign those. Oops, we'll go back and give it a description, because I think that's good. Okay. And we'll assign the description, and our start time will be our start time, end time will be our end time. Okay, so far, and if you've been following around with the other tutorials about design patterns, we aren't doing anything too crazy. We've got our contract / abstraction. We've got our context, our wrapper, where we're doing a lot of our business logic. And we also have, in this case, there we go, our detail, right? The thing that's going to be changing based off the state. So the state pattern also calls for something to handle the changing of state. And a lot of the state pattern examples get pretty complicated, and they do some things that are, I don't know, they're not really advanced per principles or techniques, but they're I don't know, they're a bit obfuscated, right? They're a bit confusing. So all I know is that I need a wrapper, and I need something to operate as my state abstraction. I need a way to change the state of an object. So I'm going to do a public void set state. And I do state is equal to something. Oh, hang on. This is where I'm going to decide what my new state is going to be. And before I do that, I'll talk about the typical implementation versus what we're going to try to do. So let me go ahead and commit this. Hey Guffin. Yeah man, sorry about the noise. I was out all last week and I didn't do what I promised, which was to look into the mic. And I think it's actually the dB gain on this particular microphone and my setup. So it's going to take a few more tweaks before I can really get it down. And the way that I reconciled that with myself was by saying that I'm going to be doing so many more streams, and I'm going to be redoing all these katas in the future that I'll have plenty of time to get it right. It's kind of a weak excuse, but we'll get there. Okay, so I committed that. So the next step is to create a few state implementations. So typically, and if you look online at some of the other state patterns, what they would want you to do is to take in a new state here, state, and state equals state, right? And then much like the strategy pattern, you'd have some other method here that would be like int calculate ticket price, and then you return the current state dot calculate ticket price, right? So if one of your states was 10 days until the event and your price was X, but if you were 20 days from the event and that was your state, then your price would be Y, right? So when you change the state, it's going to affect the behavior of the class. I have no problem with that. I actually think it's a great design pattern, but it is painfully close to the strategy pattern, which says abstract out the behavior of a class so that it can change at runtime. It's so close that it's almost redundant. So at the risk of going too far from the canon or the academics, the way that I like to view the state class as being a very, very light behavioral pattern that helps to drive deeper behavior. So, and what I mean by that is I don't want to take in a state, because what this forces me to do is to ask the calling layer to create a new state and then pass it in. It's a lot of responsibility for the calling layer. It's not something that I necessarily want the calling layer to do. I want it to pass me in some information that could affect my state, and then I'll decide what that means. If it affects nothing, it affects nothing. If it actually does dig deeper into some other functionality, so be it. But it's not for the calling layer to decide. So instead of just bringing in state and setting state, and if I did that, the kata would be over, right? That's really how simple the state pattern is. What I want to do instead as an example is to take in a date time call that time. And then I want to perform some logic based off of that. Presumably because time is something that could be coming from the calling layer. If I was writing a web app or even a mobile app, and someone wanted to look at an event and see its current state, whatever that means, it could feed me the current time from that device or from the server or wherever, and I could then decide the state of the event and then show the corresponding data or options. So that's our divergence away from the classic state pattern. I think you get all the benefits of the usual approach in the strategy pattern. So that comes to, well, we need to create a few state implementations. So we need to create upcoming and, what did I say, started or ended. So we could come here and create 3 new classes, one called upcoming, one called started, and one called ended. I think we're far enough along here that we can kind of condense that a bit. And so instead what I'm going to do is I'm going to come right down here. Oh, not here, sorry. My social event state. And I'm not actually going to inherit this anywhere, so I'm just going to make it a class that can be newed up. And then inside of my social event, I'm just going to add a folder called data. So I'm going to add a new item. Super simple, I think. I'm just going to call it available states. And I'm going to say public static social event state upcoming is equal to new social event state. I'm going to use the object initializer to give it a name, upcoming, and a description. Just one more time. Started. Just make that started. And the description is equal something that's happening now. Ended is equal to new social event state. Name is equal to ended. Description is equal to this event has ended. Alright, so why did I do it this way? Why did I just create 3 different classes? Well, a lot of the design patterns that are out there, a lot of the ways that we've been doing it up until now, simply aren't realistic. You could have, depending on the pattern and the target, you could have 50 states. You could have a variety of concrete implementations. And typically those are going to be stored in a database, and you'd be editing them, saving them, providing an admin kind of console to manage that data. You wouldn't want to come in here and mess around with classes or code to make those kind of what should be very simple runtime changes. So to kind of mimic real life, we're just going to add a data folder. This could be a data context, it could be a database call, or whatever have you. We don't really care. All we care is that we've got some data in one place that we can pull from. Alright, so create a few state implementations. Let's go ahead and commit. Okay.